Hello student, very good morning to all of you. I hope you all are happy, healthy and fine at home. Did you remember what were we discussing yesterday? I think we were discussing about retrosynthetic analysis and its synthesis of some of the target molecule. So far we have discuss the five target molecule whose synthesis as well as how to do retrosynthesis with the suitable example. We have seen that one. Now what we are going to discuss today, look at here on the blackboards. So 6 number, consider the target molecule 6, and which is the target molecule here? The target molecule will be this one, pH. Then pH, as we know that, everybody know that pH means phenyl group. Then here pH CH-2, then here CH, I am writing C double bond O ET, another one C double bond O and ET. So this is the target molecule number 6. It is a somewhat complicated, but let us see over here what is our first thing to do. First one is a retrosynthetic analysis. First part is a retrosynthetic analysis, full form. And as we know that retrosynthetic analysis means what? The process of breaking down target molecule into convenient starting material using disconnection and functional group interconversion is known as retrosynthetic analysis. In every target molecule, first thing we are using the retrosynthetic analysis, and every time we are defining that so that you can familiar with those words, because you never heard these words before, because at T.Y.B.Sc level this is the new topic introduced in your syllabus, and therefore I am altering, I am pronouncing, I am using these words frequently. The reason behind it, you should get familiar with those words, so that that's why I am bombarding these words again and again. So the aim of altering these words again and again, you must get familiar with these words. And so let us see again as a retrosynthetic analysis. When I am defining this definition of retrosynthetic analysis, it is a art of planning the target molecule is called as a retrosynthetic analysis. This is another way of defining this word, and this word, the process of breaking down the target molecule into convenient starting material using disconnection. I am focusing, I am highlighting this word disconnection, using disconnection and the functional group interconversion FGI is known as retrosynthetic analysis. These two words are highly important one again. In a definition in itself involving as a two important word. Which are those? One is a disconnection and second one is a FGI, and both the words are again very important, and we discuss those words, those terms with their example. Disconnection means what? There is a one symbol, the meaning of that symbol also we have seen. This could be made from. So that is the meaning of that. And sometime in many cases we are writing FGI over disconnection, and FGI means what? Disconnection means what? Disconnection means what? An analytical operation which break a bond and convert a molecule into a convenient starting material is known as a disconnection. And the FGI, functional group interconversion, means what? Which we usually written on the disconnection arrow. The meaning, the definition of that FGI, one of the functional group is converted into another functional group so that disconnection becomes possible, is known as a FGI, and both these terms are frequently using in a retrosynthetic analysis. Now let's do the analysis of the retrosynthetic analysis of this molecule. Now what is our first thing to while observing this molecule, target molecule, observe this target molecule carefully and notice what are the thing to notice. The first thing, you must recognize, you must identify the functional group. And functional group, I am always talking about that functional group. The organic compound containing as a functional group means there is a site of reaction, means whenever we are adding as a reagent, only that small part is gone changing, so that particular part is known as a functional group. Or in a other way around, we can define the definition of the functional group, the atom or group of atom that determine the physical property as well as chemical property of a particular family of the organic compound is known as functional group. And now here recognize, identify the functional group here. If you look at this side, there is a ester group, it is also as a ester group, but here you have to think other way around. They are in the one molecule, but so this is we have seen in a first chapter. We have learned two synthetic reagent and its application, how they have synthesized in the laboratory. Their synthesis also we have seen, we have discussed. So if you see over here, it is there are the two possibilities I am showing over here. One I can break from I can break this bond between that benzyl ring and the CH2. This I am saying it is a possibility of breaking that bond. Another, look at here, I can break this also bond, that I am showing over here as a B. So there are the two possibility, there are two route. I can break these two bond in a two different way, A and B. After breaking as a bond between, suppose let us see over here, I am writing showing here disconnection arrow, A route, and another route I am showing here is a B route. When I am disconnecting A via A route, suppose here I am writing this one is a pH, another one is a CH2, then CH, then C double bond O, OET, another one C double bond O and ET. Pay the attention carefully. Once you pay the attention, or if you pay the attention, I already told you that if you pay the attention from the beginning, then it will be very easy organic chemistry. If you are not paying the attention properly, then you will be in a big difficulty or in a big trouble. So remember that words. If you are listening or observing this reaction, why I am breaking here. After baking, after the fragmentation, I must put positive and the negative charge, means I am getting the synthon. Synthon, as we know that synthons are associated with polarities, or after the breaking whatever positive and negative charges, that type of the species are obtained are known as synthon, and these are the synthon. Now we can put here the negative charge, or you can put here is a positive charge. Either way round, you can put here is a positive charge, here you can put as a negative charge. Both are possibilities are there, but here I already told you that while breaking you should use your common sense, or what we can call it as a you think logically. If you think as a logically, then and then you will find the way of putting that positive. So this is a probably is the most correct way of representing that molecule, so that we can get this one. So let me clean this one, and now once I got these are the synthon, right? These are the synthon which I got over here. This is also as a synthon, and after that synthon, every synthon and synthon are very unstable, and for to get the stabilize means what they are there, you have to find out the synthetic equivalent, and every synthon must have a reasonably synthetic equivalent, then and then you can use it for in your synthesis. Otherwise, if you not getting as a proper synthetic equivalent, you cannot use it for the for your synthesis. So do remember this one. Now here the synthon, which, and as I already told you, whenever there is a negative carbanion type of the species are there, you always attach a metal over there, so that you can maintain its nucleophilicity of that carbon atom, and therefore you can make it here pH. Then here there is a Mg and Br, which is a synthetic equivalent over here, and this synthetic equivalent you can again proceed, or you can get from the bromobenzene, right? So but let us see over here, when I am putting as a positive charge, you should connect the negative atom, and generally here you think you know that halides are the element which can induce the polarity. They are maintaining the positive electropositivity, or the what we can call it as a electrophilic nature of that carbon atom, so that you always remember while showing as a 3 line that clearly indicate that this has a synthetic equivalent. So you can use here Br, then CH2, then CH, then C double bond O, OET, and here C double bond O, OET, and this molecule you can further do. But as far as the T.Y.B.Sc level is concerned, you think you should leave here, just think it is enough. Okay, now if you see other way round, that is a B way, I am showing over here for the what we can call it as a here the space. So I am just changing the direction of that arrow. Let's see over here. After breaking as a B bond, think of B root over here. After breaking fragmentation, what I get over here, pH, then CH2, and then CH, C double bond O, OET, and here C double bond O and OET, right? Now when I am breaking the B bond, B root, when I am choosing the B root, now the next after the fragmentation, now I must put positive and the negative charges on those carbon atoms. So now but while putting positive and the negative charges on those carbon atom, before that I must think logically, where should I put the positive charge, where should I put the negative charge. In that way you have to think, and after thinking you must apply your common sense over there. And if you are not thinking in that way, then you will be in a big trouble. So remember, over here in a first chapter we have seen this, if you see over here that carbanion, if I am putting over here, suppose as a minor charge over there, I should put here, and the positive charge I must put here. This is the better way, this is the very what we can call it as a correct way of representing plus and minus charge. If you look at here, this carbanion is well stabilized due to the resonance effect, because that is a CH carbanion. It is present in between is a two strong electron withdrawing group, and that's why it is greatly stabilized, and by that minus R inductive effect and the minus R inductive effect. And therefore if some of them is not thinking, not using their common sense, what they will put, they will suppose some of them you might be putting as a negative charge and positive charge here. So just think about here, negative charge, here you can maintain the polarity by attaching as a magnesium metal and the Br, Grignard's ring. But here these carbocations are highly unstable, because there are the electron withdrawing group, they are destabilizing that carbocation. Electron withdrawing group always destabilizing the carbocation, and therefore this possibility do not show such a type of the positive and the negative. The better way to represent, you place the positive charge here, you place the negative charge here, and then these are the, what we got, these are the synthon, right? These are the synthon. And once you got the synthon means what? The reagent carrying, synthon means what? They are associated with polarities. After the breaking of that bond, whatever positive and negative species are obtained are known as a synthon. And the synthetic equivalent, each and every synthon must have a synthetic equivalent. Synthetic equivalent means what? A reagent carrying out the synthetic equivalent means what? A reagent carrying out the function of synthon is known as synthetic equivalent. And because that synthon are highly unstable, and they must have a synthetic equivalent. The synthetic equivalent, look at here, observe this molecule, observe this fragmentation carefully. What do you see over here? Here is a positive charge. So which atom I should bring? I should connect here. I must connect here is a halide group, pH, then CH2X. Let us see here, I am connecting as a Br. Br is an atom more electronegative in nature. It maintaining the electrophilic nature of this carbon atom. Positive charge, then negative charge over. And now which atom I should bring here? I should bring here CH2, then C double bond O, OET, then C double bond O, OET. And as we know that this is a synthetic equivalent, the name of that synthetic equivalent, or it is a synthetic reagent, and this is also known as a synthetic equivalent, as well as it is known as a synthetic reagent also. Synthetic reagent. A reagent means what? A compound react to give an intermediate in the planned synthesis, or the target molecule itself is known as a reagent, and this is the malonic ester. Remember, this is the malonic ester which we have discussed in our previous in our first chapter, right? First chapter, the name of that chapter is a carbanion and their reactions, because this malonic ester possessing the CH2 group, it exhibit the CH2 group, and the CH2 group have a special name. What is it? Do you remember? Yes, what is that? It is a reactive methylene group. And what do you mean by the reactive methylene group? The CH2 group is present in between, the CH2 group is flanked in between two electron withdrawing group is known as reactive methylene group. And by using as a sodium alkoxide, methoxide, whatever base we can use there, we can make as carbanion, and that carbanions are well stabilized due to the resonance, and that's why this CH2 is known as a reactive methylene group. And this can be obtained from, you can do the FGI functional group interconversion, and you can be obtained from CH2 and OH, right? And once you prepare that alcohol, and alcohol can be obtained from, there are the different, but up to this you can remember these are the way to represent this molecular, this alcohol can be broken like this way, and you will get here this pH means I am writing here like this is a phenyl group minor charge and plus SC double bond OH. That is a formaldehyde, and this is a carbanion. Again we are getting over here. This is a synthon, not the carbanion. Let me correct that one. Synthon, and synthon must have a synthetic equivalent. What is that? This one, pH, Mg and Br. I am writing over there, and pH, Mg, Br again obtained from pH and Br bromo. So in this way we can prepare, we can synthesize this molecule. This is whatever we have discussed so far. Whatever we have discussed, these all are included in the retrosynthetic analysis. Got it? This is a retrosynthetic analysis. Now let us start as a synthesis. Synthesis, you start from this. If you go that way, A and B, and find out which one is a better way to synthesize that target molecule in the laboratory, that you have to find it. So now let's see over here how do you synthesize this compound. Let me clean the board first, and I will show that actual synthesis, how I can synthesize here. Because if you are in an exam, once you do the retro, so you have to go backward, arriving at the final product, or you can easily achieve the target molecule by using proper reaction condition and the suitable reagent. Now let us see, first one is a route over here. In the A route, do you remember what are the point we are getting in? I think in a B route we have got over here pH, then here is a, I think pH, Br, that will be treated Mg. In presence of dry ether we are getting here pH, Mg, Br, Grignard's reagent, right? And that Grignard's reagent further treated with this molecule Br, then CH2, I think we have written over there, right? And then CH, C double bond O, OET, then C double bond O, OET, right? Now here the difficulty is that this A route is a what we can call it, not a good one, because that pH minus is going to react with that carbonyl group, which is a better nucleophilic than this one. But let me show over here, this is going to attack over there, and you may get your target molecule, right? This is your target molecule you are going to get. Target molecule number 6, right? Now this is not a good this is not the good way. This route is not good way. Now let us look at as another B route. B route, why that B route is good? Let me show you here. Just we know that this one again is a pH Br plus Mg in presence of dry ether. Why I am using dry ether? I already told you that in my previous lectures. So here pH, then Mg Br, and that will be treated with formaldehyde HC double bond OH, right? And this is attacking on this carbonyl group, and you are going to get over here pH CH O Mg Br. This is a hydrogen I am placing there, another hydrogen I am placing over here, and now this bond is a very labile bond. After the hydrolysis H2O in presence of H plus, what I will get over here? After that I am going to get here CH2, that is a benzyl alcohol, right? Once I got the benzyl alcohol, I am calling it as a A over here. Now other way around, in the other, that is malonic ester, as we know that here CH2 C double bond O OET, and there C double bond O OET, right? This is first we can call it as a. Second one, when I am using here the reagent sodium ethoxide, right, which is a reagent I am using here, and after using that, what it will do? It will abstract the acidic proton, and here you are going to get the carbanion formation C double bond O OET, and then next one C double bond O and OET, right? We can call it as a B over here, and adding as a A, not this. This is not the A. This I should use over here is a PCl5 or PBr05. What I should get over there? pH, then CH2Cl, and then I am calling it as a, and that A, now A plus B give me the target molecule 6. Understood this one? A plus B I am getting as a target molecule number 6. How I am getting? Let me show here again. So this is a better way. Let me draw. A is here pH CH2Cl, that will be treated with CH minus C double bond O OET, and another one C double bond O OET. What I should get here? This negative is going to attack on that CH2, and Cl is going to get departs, and finally I must get the target molecule. This one pH CH2, then CH C double bond O OET, and this one C double bond O and OET. Because these carbanions are well stabilized due to the resonance, and that's why both the syntheses are highly in a previous case that synthon are highly unstable, and that's why that is a less what we can call it as a less stable one. And so in this way we can discuss the retrosynthetic and the synthesis of such type of the target molecules are there, right? So this is a way of showing or representing the target molecules. I think with this, let us do you understand this? Among this A and B, which one do you think is a better way? So let us see here. B is the better route for synthesizing such type of the compound, because in the A, whatever synthon we got, both the synthons are highly unstable. We cannot have their synthetic equivalent, proper synthetic equivalent, and therefore we cannot prepare such type of the target molecule. But if you see the B route carefully, you will observe there the whatever fragmentation we got. So PaCH2 plus, it have a proper synthetic equivalent. Synthetic equivalent means what? The reagent carrying out the function of synthon is called as a synthetic equivalent. So there we have got the synthetic equivalent is a PaCH2Cl, and then this can be obtained from benzyl alcohol. Benzyl alcohol can be obtained from that one after formaldehyde and the Grignard's reagent. Grignard's reagent can be obtained from the bromobenzene or chlorobenzene. So in that way you have think that is a better way, B route is a better way of synthesizing that target molecule. I think with this, let us stop today here. Remaining some of the retrosynthetic molecule we will learn tomorrow. Have a nice day. Thank you.